Okay? You can't combine an x with a y, and you can't combine a square root of 5 with another square root other than the square root of 5. So these are considered like terms because they're both square roots of 5. So as long as you're adding or subtracting, all you do is you combine the numbers out in front. So the numbers out in front are kind of like the coefficient of your square root. So you just combine 3 and 4. 3 and 4 combine to be 7, and then you keep the square root of 5. You don't add the numbers underneath the square roots. Those are considered like terms. So 3 square root of 5 plus 4 square root of 5 is 7 square root of 5. You combine the coefficients and you keep the square root just the same. Alright, example 11. We're adding and subtracting square roots. So if we have 2 square root of 7 plus the square root of 7. 2 square root of 7 plus the square root of 7. Again, we can't add these two terms unless we have the same number under the square root. Y'all both see 2 square roots of 7s? So those are like terms. What's the coefficient of the second square root? It's an understood 1. So if there's not a number out to the left of your square root, you can put in a 1. So now your coefficients would be 2 and 1, and 2 plus 1 would be 3. Keep your like term, which is the square root of 7. You're never going to add the numbers underneath the square roots. They are considered to be like terms, and you just always bring that square root down. All right, example 12. They'll throw a few of these in here. They'll make you think that you can add or subtract, and you won't be able to. So if we have 2 square root of 5 plus 3 square root of 7, we're not going to be able to add 2 square root of 5 with 3 square root of 7 because one term has square root of 5 and the other term has square root of 7. And we can't add and subtract square roots unless they're exactly the same. So this problem is actually it's the answer. Okay? And they'll do that to you sometimes. They'll give you a problem that's already simplified. And again, we can't add a square root of 5 with a square root of 7. They have to be exactly the same number underneath the square root. Alright, they may even give you 3 radicals at a time. So example 13 is 10 square root of 6 minus 3 square root of 6 plus the square root of 6. So this time you have 3 terms. Well, that's no big deal. You're going to check to see if they're like terms. 10 square root of 6, 3 square root of 6, square root of 6. You see all the square roots of 6's? That means they're like terms. So you're going to combine their coefficients. So their coefficients would be 10 minus 3 plus an understood 1. So 10 minus 3 is 7. 7 plus 1 is 8. Keep your like term, which is the square root of 6. All of those radicals were the square roots of 6's. So they're technically, all of those are like terms. They're all 3 like terms because they're all square roots of 6. So you just combine the coefficients out in front. All right, example 14. Six square root of 3 minus the square root of 7 plus 8 square root of 3 minus 6 square root of 7. Six square root of 3 minus the square root of 7 plus 8 square root of 3 minus 6 square root of 7. Does everybody agree we're adding and subtracting in this problem? Pluses and minuses. Okay? Now, you have 2 different radicals here. What are they? 3 and 7. So the 3's are like terms, so I like to underline those once. So 6 square root of 3 and 8 square root of 3, you'll be able to combine those because those are like terms. And then I'm going to underline negative square root of 7 and negative 6 square root of 7. I'll underline those because those are like terms. You can only combine the two terms that have the square roots of 3's, and you can only combine the two terms that have the square roots of 7's. So let's look at one at a time. The square root of 3, what are the coefficients? 6 and 8. What is 6 plus 8? 14. So you're going to bring down 14 square root of 3. Now look at the square roots of 7's. What are the coefficients on the square roots of 7's? A negative 1 and a negative 6. What's a negative 1 and a negative 6 combined to be? A negative 7. Okay? So you're going to have negative 7 square root of 7. You just keep the radical and you only combine the numbers out in front. And that's your final answer, because 14 square root of 3 can't be subtracted from 7 square root of 7, because those are considered unlike terms. Square root of 3 and square root of 7 are unlike terms. Okay? Now, before I get any further into some problems that are a little bit harder, is there anything about 14 or anything that we've talked about that doesn't make sense that you'd like to ask a question about? You're tired? That's a statement, not a question. Two more examples, and then you can start your homework. All right, example 15. Yeah, it's that stuff that you're going to have to do to be able to pass honors geometry.
I was just kidding.
I'm not kidding.
I mean, I was kidding, but then again, I wasn't kidding. But I was like kidding to the point.
Thank you for clarifying that. Now it's more complicated than it was before you clarified it. 3 square root of 24 minus 2 square root of 6. 3 square root of 24 minus 2 square root of 6. So the first thing that you've got to ask your brain is, are these like terms? Okay, they're not. The square root of 24 and square root of 6 are not like terms, but whoever said that is correct, but they said they could be. They possibly could be like terms because 24 under the square root can be simplified. Okay? So you're going to have some problems in your homework. They'll be towards the end of your homework where they give you a radical that needs to be simplified. So you need to simplify before you add and subtract. Okay? That's why we studied simplifying square roots. So 24 is not a perfect square, but the largest factor of 24 that is a perfect square is 4. So we're going to rewrite 24 as 4 times 6. How about 6? Is there any factor of 6 that's a perfect square?
36.
Will 36 go into 6 though? Remember, factor means something that will divide into 6. Will 4 divide into 6? Y'all are scaring me. Alright, 6 is simplified. 2 is not a perfect square. 6 is good. 6 is good. Okay, we rewrote 24 as 4 times 6. So now we can take the square root of 4, which is 2, and the 2 comes out, and if there's already a number outside, those numbers get multiplied together. So 3 square root of 24 is going to turn into 6 square root of 6, and then you bring down, subtract 2 square root of 6. Now, once you simplify 3 square root of 24, you do have like terms. You do have 2 square roots of 6's, so you just subtract the coefficient. 6 minus 2 is 4. Bring down your square root of 6. If you have a square root that will simplify, you need to go ahead and simplify that first, then look for your like terms, and then combine your like terms. Okay? Questions about 15? Anybody still copying 15? Got one more. Alright, example 16. Last example underneath add and subtract. Example 16. 4 square root of 75. So as you're writing this, I want you to be thinking, is 75 a perfect square? No. Does it have any factors that are perfect squares? Yes. What goes into 75 that's a perfect square? 25. Alright, I'm not finished. Minus 3 square root of 48. Is 48 a perfect square? No. Does it have any factors that are perfect squares? Yes. What's the biggest factor of 48 that's a perfect square? 16. Okay, and the last one, minus the square root of 27. Is 27 a perfect square?
No, ma'am.
No. What goes into 27 that is a perfect square?
9.
9. So all three of these square roots have to be simplified in your first step. Okay? All right, and we're going to simplify just like we've always done. The largest factor of 75 and the only factor of 75 that is a perfect square is 25. So we're going to break 75 down into 25 times 3. You got to be careful with something like 48 because some of you are only going to factor out a 4. But that would give you 4 times 12, and 12 still has a factor that is a perfect square. So the largest factor of 48 that is a perfect square is 16. You're going to want to pick the largest one or you're going to have an extra step of work to do. There's only one factor of 27 that is a perfect square, and that is 9. So in this first part of our problem, we've got to simplify all the square roots before we can add or subtract. So what's the first radical turn out to be? Take the square root of 25, which is 5. 5 times 4. Some of y'all will start doing this in your head. 20 square root of 3. If you know what you're doing and you can skip a few steps, that's fine. If you don't know what you're doing, show every single step. Everybody know where the 20 came from? 5 comes out. 5 times 4 is 20. If you need to write it, you can. Next one, square root of 16 is 4. 4 times negative 3 is negative 12. 3 stays under the radical. Last one, square root of 9 is, okay, 3 comes out, 3 stays in. So everybody get that step? And then voila, now we have uncovered that once we have simplified the radicals, that we do have like terms. They're all square roots of 3's. So 20 minus 12 is 8, and 8 minus 3 is 5, and we keep our like term, which is the square root of 3. 5 square root of 3. That had a lot going on in it. We had to simplify, and then we had to go back and combine like terms.